We said that the world of maths has many laws, but to be honest, not exactly. No, it still has many laws, but not too small like the world, because it's so much more than that. Maths is an entire universe, and just like our universe, it is complex and continuously expanding. So far, we have only looked at real numbers like fractions, integers, and irrational numbers, using them to solve different equations. But hey, there's one more equation left. Best for last, right? Let's try to solve it. After taking the square root on both sides, we get root minus 1. That's a really interesting value because there's no real number that can represent that. It's imaginary. Mathematicians write it with an I, also called iota. The concept of imaginary numbers may sound strange. You don't use them to count imaginary chocolate bars or fake money in your wallet. But they do have very powerful uses in some important fields, like electrical engineering. On top of that, they are not very difficult to use. When you multiply I with any real number, you just get another imaginary number, like 2i or minus 3i. Imaginary numbers can also be in the form of fractions and can also be multiplied by irrational numbers. And I on its own is just 1 times I. Now, how about we raise the bar? What if you add an imaginary number to a real one? You get something completely new, a complex number. Contrary to how it sounds, it is not at all complex. We just call it that because it's a complex of a real number x and an imaginary number with a real coefficient y, where, of course, I is root minus 1. Let's see this in practice. Suppose x is 3 and y is 4. What does their complex look like? Awesome! How about when x equals 2 and y equals minus 1? Easy. Simplify this a little. And there we go. Now, let's try setting y to 0. Assuming x is 5. Anything multiplied by 0 is just 0. So we are left with 5, which is real. What does that mean? All real numbers are also complex numbers with imaginary parts as 0. Who's the bigger boss now? You got it. Okay, let's see what happens when we raise I to a power. Starting from I raised 1, which is I of course, but square it, and we get minus 1. Trying the power of 3, we have I squared times I, making the final answer minus I. How about I to the power of 4? That's I squared twice, which we remember as minus 1. And minus 1 times itself is just 1. Let's further increase the power of I and see what its value will be. Start by isolating the powers of 2 and 3. We already know what these values are, so let's plug them in. And we get I again. If you solve for the 6th power next, then in the same way, you will get I squared, which equals minus 1. Do you notice a pattern? After the 4th power, the answers start to repeat, like I to the 5th power is just I, and I to the 6th power is same as I squared. Similarly, I to the 3rd equals I to the 7th. And of course, the 4th and 8th powers equal each other. Thus, the cycle continues. Makes things much easier, right? How cool is that? We can use this to predict larger powers, like the 13th. It's just the first power, which you can confirm using a longer calculation. And there you have it, friends, a neat introduction to complex numbers. We promised it wouldn't be hard, and it wasn't. Am I right? Our mathematical universe definitely has complexities like our real universe. But thankfully, the mathematical ones are much easier to understand. So tune in to our next lesson as we perform different operations on these complex numbers.